Hello students. Hello and welcome to this video. In this video, we will solve question number 81 to 90 of determinants. The link to download the PDFs will be in description, as well as at the end I will show you how you can download the updated PDFs from my website. And I will also show you my question answer website where you can come and ask questions or give answers. So without further ado, let's get started. Question 81 says that we have to determine the nature of this system of equations. That is x plus y minus z is equal to minus 2, 6x plus 4y plus 6z is equal to 26, 2x plus 7y plus 4z is equal to 31. So we evaluate delta. Delta is minus 72. Delta 1, delta 2, delta 3 all are non-zero. So the given system of equations has unique solution. It is easy, just you need to evaluate the determinants. Okay. Now question 82 says that find the value of k such that there is something wrong in this question. Okay, we'll see. Such that following system of equations possess a non-trivial solution over the set of rationals Q. For what value of k, find all the solutions of there is some pattern mistake. For that value, not what value, for that value of k, find all the solutions of the system. So this is x plus ky plus 3z. Instead of plus, I have typed underscore, so it has become a subscript. So it is ky plus 3z is equal to 0. X plus ky minus 2z is equal to 0. 2x plus 3y minus 4z is equal to 0. So we have to find the solution such that it is non-trivial, that is delta should be equal to 0. So we write the delta 1k3 quotient of x, xyz of first equation, and then 3k2. How come this is 3k minus 2? This should be 1k minus 2. Okay, let me see. This is indeed 3. So there seems to be a typing mistake here. There should be 3 here. Okay, then we have 2, 3 minus 4, 2, 3 minus 4. We relate. So, irrespective of typing mistakes, you follow the methodology. So, we set the value to be 0. It comes out to be 33 upon 2. Now, once we have k is equal to 33 upon 2, we solve the equation. So, we get 2x plus 15y is equal to 0 and x plus 5z is equal to 0. So x is equal to t, y is equal to minus 2t upon 15, z is equal to minus t upon 5, where t is an arbitrary number. Question 83 says that if A, B, C are different, show that the following system of equations has non-trivial solution only when A plus B plus C is equal to 0. The system of equation is ax plus by plus cz is equal to 0, bx plus cy plus az is equal to 0, cz plus ay plus bz is equal to 0. So we have this delta and we know how to evaluate it. We say column 1 is equal to column 1 plus column 2 plus column 3. So our column 1 becomes a plus b plus c. So we have got a plus b plus c out. And then these become 1, 1, 1. And we perform our usual R2 is equal to R2 minus R1 and R3 is equal to R3 minus R1. We get 2 zeros. And we get the final determinant of the calculation of all this as minus half a plus b plus c, a minus b whole square plus b minus c whole square plus c minus a whole square. Now, since a, b, c are all different, okay, it is given that they are different. So the term inside this bracket is will not be 0. It can't be 0, right? This will be a positive number, positive and positive. Now, delta will acquire the value 0 only if a plus b plus c is equal to 0 for non-trivial solutions. Question 84 says that for what value of lambda the following system of equations have non-trivial solutions. 3x minus y plus 4z is equal to 0, x2y minus 2z is equal to 0. This labels again seems to be a typo mistake. It should be x plus 2y. And 6x plus 5y minus lambda z is equal to 0. So what we do is let me see if this is 1 to minus c, yeah, 1 minus c, 3 minus 1, 4, 6 for lambda, yeah, this is correct. This again, there is a typo mistake. Instead of plus, I have pressed underscore, both keys are nearby. So we have this determinant, we evaluate it and set it to 0, and we get lambda is equal to minus 5. Question 85 says that let the 3-digit numbers A to 8, B 3, B9, and 6 to C, where A, B, C are integers between 0 and 9, be divisible by a fixed integer K, so that the determinant A to 6, 8, 9, C to B2 is divisible by K. So we are given that A to 8, which is A times 100 plus 2 times 10 plus 8 is equal to PK. 3B9 is equal to 3 times 100 plus B times 10 plus 9 is equal to QK. 6 to C, there should have been a space. 6 to C is equal to 6 times 100 plus 2 times 10 plus C is equal to RK. Where PQ are integers and all are divisible by K, as we can see it. Okay. Now once we have that, we evaluate this delta. Okay. So what we do is we do R2 is equal to R2 plus 10 R3 plus 100 R1. So if you see, this is 8 to 8. Okay, so 8 times 100 plus 2 times 10 plus 8. And then this is, this should be 3. This should be 3. There's the typing mistake again here. So 3 times 100, B times 10 plus 9, and 6 times 100 plus 2 times 10 plus C. Okay, this should have been 3. Okay. So what we have is that our middle row, that is row 2, it becomes PK, QK, RK. And therefore we can take out K, which will be divisible by K. Question 86 says that evaluate XC1, XC2, XC3, YC1, YC2, YC3, ZC1, ZC2, ZC3. So we expand this XC1, XC2, and XC3. We get x minus 1 upon 2, x minus 1, x minus 2 over 6. And similarly for y and z. So what we do is we take out x, half and 1 by 6, y and z as well. So outside we will have x, y, z upon 2 times 6. And inside we will have 3 ones, x minus 1, y minus 1, z minus 1. And the third column would be x minus 1 times x minus 2, y minus 1 times y minus 2, and z minus 1 times z minus 2. Then we do column 3 is equal to column 3 plus column 2. We will have x minus 1 whole square, y minus 1 whole square, z minus 1 whole square. Now this determinant is similar to 1a square, 1b b square, 1c 3 square, which we have evaluated earlier. And therefore this will be equal to xyz upon 12 is equal to times x minus y times y minus z times z minus x. So that is how we evaluate this determinant. Question 87 says that if A is not equal to P, B is not equal to Q, C is not equal to Q, and the determinant PBC, AQC, ABR is equal to 0, then find the values of P upon P minus A plus Q over Q minus B plus R over R minus C. So we have this determinant, all right, and we form R1 is equal to R1 minus R2. Instead of underscore at that mass, it should be underscore here R2, and R2 is equal to R2 minus R3. And the determinant becomes P minus A, B minus Q 0, 0, Q minus B, C minus R, A, B, R. Then we expand the determinant and we find the value as R times P minus A, Q minus times Q minus B plus B times P minus A, R minus C plus A times Q minus B times r minus c. Okay. Now, once we have this, we can say that r upon r minus c plus b upon q minus b plus a upon p minus a is equal to 0. So how do we arrive at this? We divide by p minus a times q minus b times r minus c in our expression. Now, once we have that, we can write that as r upon r minus c plus b upon p minus b plus 1 plus a upon p minus a plus 1. Okay. There seems to be some mistake here. This is fine. This, if you add 1, then becomes q. Okay. So we add 1 actually. Okay. This is not equal to this. We add 1 here to second and third term. So right hand side will become 2 because we are added 2 to the left hand side, 2 should be added to right hand side. And once you evaluate this, it becomes p upon p minus a plus q upon q minus b plus r upon r minus c is equal to 2. Question 88 says that show that the determinant x minus a whole square, b square, c square, a square, x minus b whole square, c square, a square, b square, x minus c whole square is equal to x square times x minus 2a times x minus 2b times x minus 2c times x plus a square upon x minus 2a plus b square over x minus 2b plus c square upon x minus 2c. So here what we do is we do r1 is equal to r1 minus r2 and r2 is equal to r2 minus r3. So we will have this determinant over here. That is x times x minus 2a, x times 2b minus x, 0, 0 minus x minus 2b, x, ac minus x, a square, b square, x minus c whole square. We take x from first and second row out. Can we take? There should be an x here. X should be here. Let me see. So we do r2 is equal to r2 minus r3. R2 minus R3, there should be an x here, okay? R2 is equal to R2 minus R3. So this becomes 0 and there should be plus sign here as well. There should be plus sign, this should be x square minus 2bx. So this should be plus sign x and x minus 2b. Right? Seems like a calculation mistake. So this should be x times x minus 2b. So we take x common as you can verify from the next one. That is indeed the case. So we will have x minus 2a minus x minus 2b 0, 0, x minus 2b minus x minus 2c. This should be 2c, not ac. A square, b square, and x minus c whole square. Once we have that, we take out x minus 2a, x minus 2b, and x minus 2c common. So once we do that, this will be fine, this will be fine, but this is where we need to divide. So we divide here, okay? All right, once we divide it, there should be x square, that is, okay, this is good. So once we have that, what you can do is, you can say that over here we multiply with this, we take this out, and the determinant becomes this, because we from column 3 is equal to column 1 plus column 2 plus column 3. And then you have the final solution. A bit complicated and there are typing mistakes which do not help, but you can understand the gist of the problem. Question 89 says that if a greater than 0, b greater than 0, find the value of the determinant 1 upon a, 1 upon a times a plus b, 1 over a plus b times a plus 2d, and so on. So it is increasing the product of harmonic numbers. Okay. So what we do here is let me see. Okay, this will be complicated. So we multiply with a plus b whole square, a plus 2b whole cube, a plus 3b whole square, a plus 4b. That is, first row is multiplied with a plus d, a plus 2d. Okay. The second row is multiplied with a plus d, a plus 2d, a plus 3d. And the fourth row is multiplied with a plus 2d, a plus 3d, a plus 4d. So outside we will have this, we have to divide by the same stuff, and inside we have this. Okay. Once we have this, what we do is we do column 2 is equal to column minus column 3. So once we do that, it becomes 2d. Once this becomes 2d, what we can do is we perform our typical R2 is equal to R2 minus R1 and R3 is equal to R3 minus R2. So we get 2 zeros. Once we have 2 zeros, we expand along the middle column. And what we will have is minus 2d times 2d square a plus 2d minus a minus 3d. Okay, so if you take this, you will need to multiply these two. Okay, and these two here. So that's how we got the answer. Okay, these two. Okay, fine. A plus 2d minus a minus 3d. Yeah, that's good. So once we have that, we get, if we solve this, we get 4d to the power 4, and the denominator remains the same. Right. Now we move on to question 90. We have to show that 1 upon a plus x, the determinant 1 upon a plus x, 1 over a plus y, 1 over a plus z, 1 over a plus y, 1 over b plus y, 1 over b plus z, 1 over c plus x, 1 over c plus y, 1 over c plus z is equal to a minus b times b minus c times c minus a times x minus y times y minus z times z minus x over a plus x, b plus x, c plus x, d plus x, e plus y, d plus z, c plus x, c plus y, c plus z. So what we do here is we take this determinant and we multiply by this. Okay. So the first row is multiplied by a plus x plus first column is multiplied by a plus x, b plus x, c plus x. Okay. I'm not sure what it is multiplied with. Okay. So what we do is we have this delta is equal to 1 over a plus x plus this should be x. Okay. B, not b plus c, b plus x plus times c plus x, a plus y, b plus y, c plus y, a plus z, d plus z, c plus z, delta 1. Where delta 1 is this determinant. Okay. Now we evaluate this determinant. What we do is R2 is equal to R2 minus R1. Again, this is instead of underscore, it is minus. And RC is equal to R3 minus R1. And then we evaluate the determinant. We arrive finally at this value. Okay. And that's how delta is equal to the given value. So it's mathematics calculation. So please do it and pause the video and go through it. So you can see how it is done. And reading this would be not useful. Okay. It is just too much to read. So I'll just not try to read it. Now I will show you the question answer website. The website from where you can download the books. The second, third, and fourth links are PDFs of algebra, trigonometry, and coordinate geometry. The downloaded PDF will not have dates, so you can copy this date and add it to PDF. For example, this coordinate geometry was updated yesterday. I can't put the date in the PDF because that will break all the existing links. Okay, and also there are lots of typing mistakes as we have seen by now. Also, the coordinate geometry book is available in HTML format. So the math here is done using MathML. So I will recommend you to use Firefox browser. Firefox has best support for MathML. Chrome, Edge, and Safari latest versions also support MathML. But still Firefox has better support. So if you run into trouble, use Firefox. Now the question answer website, you can come by clicking H link or tapping comnipa.trustobserver.org. You can come and ask questions here. So I have already created tags for you: algebra, calculus, coordinate geometry, geometry, probability, trigonometry. And if these do not match your question, then you can use the generic tag mathematics. So you can come here and ask questions or answer questions. If you ask a question, I will try my best to solve your question. Now, why this website is done is because YouTube is not really a suitable place for dealing with math. Also, the questions get lost in the comments, but if you ask it here, it will be preserved for a long time. So with this, I'll end this video here, and apologies for all the typing mistakes, particularly these ones, minus, and you understand that you end up typing the adjacent string. So I'll end this video here, and we will meet again after tomorrow with 10 more problems on determinants. So till then, stay curious, keep learning, and most importantly, enjoy.